Welcome to Spring LIB.
Okay, we are given two blocks, A and B. Mass of A is 10 kg, mass of B is 50 kg. A is resting on B. Between A and B, the coefficient of friction is 0.2, and between B and C, which is our surface, it is 0.1. And they are connected by a pulley as shown and a rope. Okay, now we have to assume the mass of the rope and pulley is 0, and we need to determine the time taken by A to slide 0.5 meters from the rest position. Okay, so let's have a free body diagram of A. So this is a body A. Now gravity is acting in this direction, so let's have our coordinate. So parallel to plane our x-axis and perpendicular to this plane our y-axis. Okay, now this angle we know it is 30 degrees. Now gravity is working vertically downwards, so there will be a gravitational force acting vertically downwards, MAG, that is 10 into 9.81, and this is at 30 degrees. Then we have a normal force acting perpendicular to the surface of A, and we have friction force. Since we are assuming body is moving in this direction, so friction force will be acting in negative of our motion, so that is here, so mu times n, and we assume this is a positive direction. Okay, and this is a positive direction in the coordinate. Okay, so now if we apply in block A equilibrium condition of Newton's law, so we have summation of Fy forces is equals to 0, since we don't have any vertical motion, and from this we have N, which is acting vertically upward, and downward we have this vertical. So on factorizing into two components, we have here MA cos theta and there will be MA sin theta, right? So this becomes N minus 10 into 9.81 cos theta, and this is equals to 0. So on solving this we get N is equals to 84.96 Newton, and this N is normal body A. Okay, so we get a normal force. Similarly applying the Newton's condition for horizontal axis. So here now we will not have acceleration 0, so there is acceleration acting, which is A, and let's take this as, since this body A, so acceleration of A times mass of A, and we are assuming it is positive in this direction, so this will be negative. So putting the values, we have a rope with tension T in this direction, so there is tension in T. Okay, so tension is acting in opposite direction, so minus T. Then we have friction acting in positive direction, so plus 0.2 times our normal force, which is 84.96, and then we have gravity, which is also acting in positive direction. This was our gravity, so that is plus 10 into 9.81 times sine 30 degrees, right? And this is equals to minus 10A. MA is 10. Okay, so on simplifying this we get T minus 66.04 is equals to 10A of A. Okay, so let this be equation 1. Now applying similarly for body B. So for B we have a surface here and body A here. Okay, and assuming again it is moving in this direction and our coordinate up is positive and your left x is positive. Okay, so what are the forces acting on body B? We have a normal force. Okay, so we have normal force of body A. Now since body is moving in, okay, now with respect to body A, body B is moving downwards, so we have friction acting in this direction. Also with respect to surface, it is moving downwards, so we'll assume or we'll have friction at here is NB. Okay, and now we have our gravitational force acting vertically downwards. So let's take it as MBG, and normal force NB were acting perpendicular to the surface. And also it is given that this angle is 30 degrees, so this must be 30 degrees since this is a vertical line. Okay, so now we have all the components and our tension is acting, since this is a string, so tension is acting in this direction. Okay, so taking summation of vertical forces, and we know the body is not moving in the y direction, so vertical forces summation is 0. So therefore we can write NB, which is acting vertically upward, minus 84.96, which is our NA acting vertically downwards, minus 50 times 9.81 times cos 30 degree, which is a resolution of vertical force in y direction and x direction. So we have this here, so this vertical force will be acting in here by cos theta and here sin theta. Okay, and this is equals to 0. So on solving this we get our NBS 509.7 Newton. Now applying the summation of forces in our x direction, right, our assumed x direction. So that is equals to, we have tension T acting in negative, so we'll take it as minus. Okay, so this is a positive direction, right? So minus T. Then we have friction force mu C and B acting in again negative, so mu C is 0.1 times our NB we calculated 509.7. then we have mu Na, here mu is the friction between A and B, which is also acting in negative direction, so minus 0.2, 84.96, plus our gravity which is acting on an assumed positive direction, so that is 50 times 9.81 times sine 30 degrees, right? And this must be equals to, sorry, here we have acceleration of body B. Okay, now this acceleration is acting assuming in the positive direction, so minus, so this is minus 50 AB. On simplifying this we get our equation as 177.28 minus T is minus 50 AB. So let this be equation 2. Now we also know here, if we see, let's assume this is length of the string in SA and length of string SB. So we know the total length of string will be constant, which is SA plus SB. So on differentiating this 2 times or 1 time we'll get, so we get SA change in length plus change in length of SB must be equals to 0. So that gives us change in length of SA is minus times change in length of SB. And on further differentiation we'll get acceleration of A is minus times acceleration of B. Okay, now let's take this as equation 3. So we have 3 equations, all 3 are T minus 66.04 is 10 AA, then we have 177.28 minus T is minus 50 AB, and we have AA is equals to minus AB. So on solving this we get AB as minus 1.584 meter per second square, then we have AA as 1.854, sorry, this is 854 minus meter per second square, and then we have tension as 84.58 Newton. Here it is minus, so our assumed direction of upward AB motion was wrong, so AB is moving downward, or block B is moving downward with acceleration of 1.854 meter per second square in downward direction, and AA it is positive, so our assumed direction was correct, it is moving upward. Okay, so now we need to find the time taken to cover a distance of 0.5 meters. Now length moved by B is equals to length moved by A plus length moved by B with respect to A, and here again we are taking downward positive. Okay, so here SB is, so change in length of SB is equals to change in length of SA plus change in length of B with respect to A is 0.5 meter as given in our question, right? So we know the change in length of SB is minus change in length of SA. So this gives us this value. On solving this, we get change in length of SA is 0.25 meters. So this is the amount SA is going to move. So we can apply now Newton's kinematics. SA equals to UT plus half AT square, and we are solving for body A. Here it is positive because 0.5 meters is moved in direction opposite of our assumed direction, right? Below was positive, but it's moved 0.5 meter upward. Similarly 0.5 meter, and on solving this we get 0.25 meters. So substituting this value here, 0.25, here initial velocity is 0, so this term is 0, half time acceleration of A, which is 1.854 time t square. Solving this for t, we get t as 0.519 seconds, and that is our answer. Thank you.